Hello, hello. Welcome everyone to the React workshop. I'm super excited to have you all here. I know it's the last workshop of the day, so you're probably pretty tired, but I'm excited to have you all join me in learning React in an hour or your money back. This will be a pretty rapid introduction to the fundamentals of React, so hopefully this gives you a really good foundation to dive into writing good React code and like giving you a good like intuitive like basis to debug off of in the future. Just a quick reminder before we get started, if you haven't already, make sure you have done the prerequisites for this workshop. Make sure you have basic familiarity with Git or GitHub and some basic knowledge about HTML, CSS, and JavaScript, as well as ensuring that you have Node, VS Code, and the React template cloned locally. If you have any questions about any of those things, TAs will be available in the workshop channel to help out with any of that if you have any questions. Without further ado, hello, hi, my name is Jackie. I'm currently in third year of computer science, and yeah, I am currently one of the co-presidents of the club along with shooting as well. So as for the outline of the schedule, we're actually covering quite a lot, so we're going to be going pretty quickly, but the basics of what we're going to be covering is what React is and the basics of how it works under the hood, what JSX is and basics of writing React functional components, the React lifecycle, how to write functional components using hooks like useState and useEffect, and how to build a fully functioning to-do app in React. Don't worry if there's a lot of jargon in that first little bit. We're definitely going to be covering a lot of that terminology as we get more into the workshop. So what is React? I feel like React is one of those terms that floats around a lot on the internet, but nobody really ever has a super good definition for what React actually does. It seems like every industry job nowadays in front end requires that someone has React experience. But what is React essentially? The TLDR is that React is a bunch of code that you can add to your project, essentially think a library or framework that makes building websites and interfaces that react to changes when you do things like press buttons really easy. Examples of places where React apps make a lot of sense are pages, for example, where you have a lot of common UI across pages, like a shopping or a store page, or apps that require a lot of changing interface features that don't refresh the page, like think a Facebook feed or a Twitter feed. The two main features that set React apart is one, React is declarative. Declarative meaning that you tell React exactly what you want the page to look like, and it'll figure out how to do that. Regular programming languages, you tell the programming languages which steps to take, and it'll get to the answer. You tell React what the page wants to look like, and it'll figure out how to get there, which is pretty good for figuring out what you want the actual page to look like and makes debugging a lot easier. Second of all, React is component-based. Component-based meaning that you can create pieces of UI that you can reuse across different parts of your application and not have to worry about copy and pasting the same HTML code a million times. The TLDR is that React makes building UI really easy because it's really easy to reason and debug about, and reusing functionality between different parts of your app is really easy. At this point, most workshops would just jump into how the code works, but a lot of times people who do this end up just writing really bad React and just have a lot of difficulty at debugging the React code because they just misunderstand why certain things in React are done the way they are. So we're not like the other leading competitors in the workshop space. We'll actually cover the theory a little bit. So bear with us a little bit as we do a little bit of deep dive into how React works and give you better intuition for the how of React. So before we even get to React, we'll do a really brief refresher on HTML and how it works. So HTML is like the skeleton of the page. It defines the actual structure. If the web page is a house, the HTML is a blueprint that tells you what the house should look like and what's inside of it. So what your browser does is it turns this HTML into something called the DOM, the document object model. This is like an intermediate format that the browser uses to better represent HTML and to work with it. And after that, your browser turns the DOM into actual stuff that displays on your computer. So what does React actually do? It uses something called a virtual DOM. So when you actually modify a regular page in JavaScript, you have to use different functions like document.getElementById or like set the inner HTML of an element. And modifying the DOM is unfortunately expensive. It means you have to update something that the user sees. But if you're making a bunch of updates all at once, sometimes that can get really slow. So what React does is it uses something called the virtual DOM. Essentially what it does is it just combines all of the updates that you are about to do, batches them together, and then sends them to the page. So this makes React generally really fast for a lot of updating pieces of the UI that you'd otherwise have a lot of difficulty writing in regular JavaScript. We can think about it as the virtual DOM is an in-memory version of where React wants the web page to look like at some point in the future. So then React actually figures out how a smart way to combine all of them together and squeeze the most performance out of those few updates that you actually do to the web page. Another thing that React actually tackles really well is that in regular HTML and JavaScript, you end up writing a lot of duplicate code that looks something like this. You're going to be copying and pasting these product cards all over the place, and it just gets really hard to keep track of what you've changed sometimes. And if you want to change what this product card looks like sometimes, then you have to make a lot of code changes. And as programmers, we know how much we hate duplication. So, say for example, this example shop page with multiple product codes, if there's only something we could do to fix it. Introducing the React component. Essentially, what a React component is it's a JavaScript function that takes in some arguments, which we call properties or props for short, and returns something that looks like HTML. And this HTML section we call child components. Optionally, components can also contain internal state, like whether it's been placed into a cart or not, but we'll talk a little bit more about that in a little bit. Now, refactoring some of the a lot of the duplicate HTML out into React code, we can see that it reduces a lot of the duplication and gives us a lot of reusability, which is really nice. Now that's good code. Don't worry if you don't understand a lot of that syntax right off the bat. We'll get more into some more examples in a bit as well. So just to recap a little bit, props are pieces of data for components that are directly passed in. They are the arguments of the component itself. And these are things that you cannot modify from a component itself. You can think of props as read-only. Second of all, are state that you keep track of and can freely modify on your own. So these are properties inherent to yourself as a component. So in this product card example, this in-cart property, or not property, state, is a property of the actual product card itself. It doesn't depend on anything else right now. It's just something I personally keep track of. Third of all, each component is made up of child components. I'll elaborate a little bit on this a bit more, but React focuses a lot on composition over inheritance, meaning that you build up simple building blocks of components, and then you can compose them together by assembling them together like you would with regular HTML. Last but not least, you pass props and data to children to change how the component is rendered. So like we saw earlier, properties change how we display certain things in the component. So you can see right here that we have these curly brace looking things inside of our child component section. And what this essentially says is to template these arguments into the HTML. So for given these props, for example, it would tell you that the H1 is OxyClean, the description is eliminates red wine stains, and the price is call now to get 50% off at $19.95. So it makes it really easy to essentially change how a component is rendered based off of data that you pass into it. But wait, did we just return HTML from the JavaScript function earlier? How is that even allowed? For those who've written extensive amounts of JavaScript before, this concept of returning HTML from JavaScript seems kind of illegal. But trust me, there's this thing called JSX that makes it all possible. To talk a little bit about that, when you talk about what JSX is in the first place, it's the combination Taco Bell Pizza Hut of the JavaScript world and allows you to write both JavaScript and HTML in one. What it is, it's an XML-like syntax that lets us write React components like if it was HTML. The reason we would do that is it allows us to write HTML-looking code, which is a lot more readable, elegant, and more descriptive than the JavaScript equivalent. We use something called Babel. You might have seen this if you've already worked with a lot of Node projects before, but essentially Babel is a transpiler that turns more complex JavaScript into more compatible JavaScript. So in this case, we're taking extensions off of JavaScript, like this the HTML-like language, and then transpiling it back down to JavaScript that most browsers can understand. So the example that we're going to use here is the top one, is what JavaScript or what React would look like if we didn't use JSX. React has built-in functions called react.createElement, which is kind of nasty to look at, to be honest, and I'd much rather prefer looking at something more like the bottom one, which is what JSX allows us to do. So once again, this allows us to really easily express tree structure and nested behavior in our application than regular plain old JavaScript. Last but not least, we're talking a little bit more about composition once again. You may have seen earlier that we have this sort of nesting behavior. Essentially, React explicitly allows us and encourages us to use composition over inheritance, like using superclasses or whatever. I will talk about this really briefly, but there are technically two different ways of writing React code. One is class-based and one is function-based. React has very explicitly said that we are all moving towards functional components, which is what we're talking about in this workshop. But in the past, React has used classes before. Essentially, this new version of React focuses specifically around creating basic building blocks and allowing us to compose them together by essentially nesting components like this allowing us to create complex apps from reusable building blocks like headers, carts, or product pages, for example. Last thing I want to remind everyone of before we dive into some more code is information flows downward. So let's say you have some information stored at the body level. You can pass that down to the div and an h1 or paragraph tag, but it's very hard to pass information back up the tree. So that's something to be wary of when you're writing React apps in the future as well. So, of course, right now we've got to the point where we covered static components using just plain old JavaScript. JSX, and data passing using props. But this kind of misses the entire biggest benefit that React offers in the first place, which is reactivity to data changes. So how do we get a component to update how it looks when we click it, for example? To do that, we need the help of a few handy tools called the React lifecycle and React hooks. So like all things in life, components are born, they live, and then they die. Within this life cycle, that corresponds to mounting, updating, and unmounting. So mounting refers to when a component first gets initialized and then added to the user's web page. That's the birth process. Updating is any time a data or the props of a component changes or any of its internal state changes, and you need to re-render the component. And finally, unmounting involves when you scroll off the page or completely close the page or whatever, JavaScript needs to destroy everything it has on the page and return it to what it used to be, like a good steward of the planet. So what we essentially want to be able to do is we've covered mounting and unmounting with static components so far, but we want our components to be reactive as well. And to do that, we need to listen for some of these update events. So for example, say one of our props changes, if the name of a component, name property of a component changes, for example, we want that to appropriately reflect. So how do we do that? The first big intuitive step that a lot of beginner devs make is like, oh, why don't I introduce a local variable into my component? Essentially, what we're doing here is putting a local variable into a function and then trying to display that variable. Now, why would that be wrong? Does anyone have any clue why having a variable inside the body of a component might be a bad idea? Well, essentially, the biggest problem with this is that JavaScript essentially treats components like just JavaScript functions. It treats them as pure, in the sense that it calls a function every time it needs to re-render or update a component. And what happens when you keep calling a function? Well, obviously, because we have this variable inside of a function, every time you call that function, that variable is going to get reset. So this little state variable isn't going to do a lot of persisting for us. So how do we tell React to explicitly memorize like state, for example, or how many times we clicked a button? Then this is the whole point we get to with React hooks. React hooks essentially are just JavaScript functions that tell React explicitly, hey, please remember my data, or please do this when this effect changes. They are functions that allow us to hook into the React lifecycle and do things like fetch data and persist state really easily. So the TLDR, so the first hook that we're going to use for this React workshop is the useState hook. This comes into a little bit of weird JavaScript syntax, but what the essence of this React hook does is it allows React to persist a variable and tell us to remember it. And what we do is we initialize this hook with one optional initial state. So if we want to give it an initial value before we call anything, we can do that here. And it also gives us two variables. This weird square bracket syntax may be kind of new and funky to most people, but what essentially is happening here is we're destructuring an array into two items. I'll quickly demonstrate the syntax really quickly here because sometimes it can be confusing to people. But let's do node really quickly. So let's say we have an array with two items, right? We have A and B right here. If we want to destructure it like this, then we can do const AB. Wait, I forgot to assign this to something. Let's say const variable equal to a b, right? And so we have variable, it's this array right here. What this destructuring syntax allows us to do is it allows us to assign multiple variables at the same time to an array. If we do const AB variable, then A is just the first element of the list, which is A right here, and B is the second element of the array, which is B right here. So it's just essentially just syntactic sugar for destructuring an array. So let's see this in use now. So this is essentially a very basic React component that updates every time you click a button. It will keep track of a state, and every time you click a button, it'll increment the state. One important thing to note about this hook, though, is that this count variable on the left-hand side is always going to contain the most up-to-date value of the state, but this state is read-only, which means that you can never actually do count equals 3, for example. What you have to use is the second value. The second value is a setter function that allows us to tell React to explicitly update the state. So that's what allows us to do the stuff here, for example. So what we're saying with this component, I'm going to read it as if it was English, is we are declaring a function counter that takes in 0 parameters. So every time you render this function, it's going to be almost exactly the same thing. It doesn't take any external parameters. Let's tell React that we want to keep track of a variable. Let's call it count, and set the initial value of count to 0. And how we want the actual component to be rendered here is a div containing a paragraph element that says you clicked, and then substitute this text right here with the actual variable of the count state. And then we actually have this button right here that has text increment on it. And every time we click this button, we want to create this weird thing inside here. This weird syntax right here, for those who are unfamiliar, is called JavaScript arrow functions. What this is essentially doing is defining an inline JavaScript function that takes in 0 parameters and contains a body as this little segment of code here, which tells us to set the count to whatever count was plus 1. So what essentially this says is every time this button is clicked, increment count by 1. And because we told React to already track what count is, if count updates, React knows to re-render this component, even though it takes in 0 properties. But wait, that's not the only React hook that's going to be useful to us. Sometimes we want to also be able to run side effects as well. So that's where something called the use effect comes into place. Asynchronous data fetching, reacting to click events, setting recurring events are all examples of different types of side effects. The main thing you may have noticed so far with all the functions previous to us is that up until hooks, they've been pure. A pure function essentially means that every time you give it the same arguments, it's always going to return the same output. But sometimes you don't necessarily want that to happen. Sometimes you want things to persist and do weird things outside of their arguments, or like persist data, like fetch side effects, or fetch data, for example. Those are all side effects. React technically doesn't let us do that right now because we have no way to do things in between in the update state without, a use state hook. So essentially what this use effect hook is, it's kind of funky in that it takes 2 parameters. The first, which is the callback, which contains the effects of its side effect we want to run, and a callback array. This callback array essentially says that every time something in this array changes, run this arrow function inside. So what you can read this hook as is, for every time the count variable is updated, set the document title to count clicks. So what this essentially allows us to do is hook into different types of data changes, or if you don't want to hook into anything, hook into the initial mount, and then perform some sort of asynchronous operation that at later date will tell React eventually re-render the component. So if we integrate that back into our earlier example, what we can see is that we have the same code pretty much as previously, except we have this new use effect clause. So like before, we have this button on click. So every time we click this button, it increments the count by 1. Once this count is incremented, React will then see that, okay, we've updated count. Let's see if there's any use effects that have count registered as a dependency. So obviously this use effect has count as a dependency. So because count is updated, we set the document title to count clicks. And hopefully that makes sense to everyone. Let me just get some water really quick. Cool. Moving on. Obviously, that was a lot of talking about React code without actually writing any code. So in this next little bit of the workshop, we're going to get a little bit more hands-on and build an actual functioning to-do app. So at this point, if you haven't already, make sure you've cloned the repo that is provided, the min-react component, the min-react repository. Make sure you have Node installed, all that good stuff. I'll do a quick 3-minute break right here just to let y'all do that. If you have any questions, feel free to message in the Discord. But I will be having a quick water break in the meanwhile. Back everyone. Hopefully y'all had a chance to get some water and a little bit of break. There is a difficulty poll in the Discord. If you would please react and let me know how the speed of the workshop is so far so I can adjust for the future. Yeah, Hermit98, the slides are going to be shared afterwards as well. Yeah, you'll have time to look over this. Okay, if everyone has their terminal open, we're going to get started with the coding section of this this workshop. So if you haven't already, navigate to an empty folder, clone the Git repository, do something like that, open up VS Code, and we can navigate and find our folder and then open it up as well. So go to projects, main React, open. So I'm going to give a brief overview of kind of the structure of this repository, because I know for a lot of people, the first time they see a React repository, it's kind of spooky. The main reason, first of all, I'm not using the default Create React app is I think a lot of the times Create React app has a lot of extra boilerplate that can be really confusing to people who are new to React. So I've kind of made a stripped down version of Create React app right here to kind of minimize the amount of confusion and just give you basically the minimal of what you need to get a React application up and running. So to start off with, you may have remembered earlier that we have all of the entire JavaScript and JSX stuff, right? But the base of the web page is still HTML. So what we have right here is the actual base of the document. And we remember from earlier that we have the virtual DOM, right? And we need to eventually be able to insert the virtual DOM into the actual HTML web page. So what we do right here is we define a root tag right here in this main index.html that we insert all of our JavaScript code into later. So if we look at index.html, we define our entire app right here, right? We import all of our apps, we import our CSS, and we tell React to render this entire React app into this root element. So if we go back to index.html, this is our root page, right? And it contains this root element. So all of our React app stuff is going to be inserted into here after we start running this entire thing. Well, this is, before I go into this, completely deep dive into this, I'm going to start off by installing the dependencies of this project. So I think you may have remembered from Kevo's workshop, we talked about Node Package Manager. What this essentially lets us do is deal with all the dependency of this workshop and install them really, really easily. So what we're going to do right now is tell npm to install all the dependencies in this folder. So we're going to change directories into the React folder. And then we're going to run npm install. And this is going to take a little bit of some time, but it's essentially going to look inside package.json. Package.json tells npm exactly what our package is, what packages my package depends on, and how to run it. So what we're doing here is we're telling npm to look inside package.json, find these dependencies, and then download them from the internet and put them inside this node modules folder. You may have seen a lot of jokes online about this node modules folder being really thick, and that's because React's ecosystem is really large, so it ends up downloading a bunch of different libraries. But normally you don't ever have to open this folder, so you shouldn't have to worry about it. But yeah, so that's essentially what package.json does, is it defines what our application is, what it requires, and package.lock is essentially a checksum file, which essentially tells React, hey, here are all the things I've installed already, and here's a version I installed them at. So in the future, if we ever need to get the same version of something, we can look it up in package.lock. So that gives you a brief overview of what public and these package files are. Now moving into SRC. SRC usually stands for source. This contains all of the source code for our application level stuff. So the main stuff we'll look at first is this index.js. We covered this really briefly earlier when we were talking about how this is essentially just taking all of this this entire app JavaScript and injecting it back into HTML. Now we can navigate into app and see what it actually contains. So this app.js, essentially, we're importing a bunch of other components in this components folder and then rendering them here. Once our npm install is completed, what we can do is do npm run start. What this tells npm to do is start a local development server on your computer, so we can see our React app live and in action. So I'll give that a few seconds to start up, and it should appear on this page right here. So I'm going to move it over to one more desktop. But we will give it a few seconds to boot up. But once this is done, you should now see this minimal React template. And if you inspect element, actually, you can see the actual underlying structure of our application. You can see that if we collapse div ID root, this is exactly what we have in index.html. React has just reconciled that virtual DOM we were talking about earlier and turned it into actual HTML right here, which is pretty cool. If you find yourself writing a lot of a lot of React in the future, a really good extension to add is the React developer extension. I don't have it installed right now, but it makes debugging React a lot easier. So that's essentially the template we're going to be going off of. So for the purpose of this workshop, we're going to strip things down even more. We're not even actually going to use the entire components folder. What we're going to do, delete this entire folder entirely, move to trash, delete all of it, delete these imports because we will not be needing them anymore. And we're going to be doing all of our work inside app.js. So for now, what we can do is let's just replace our entire app with a header that says to-dos because we're making a to-do app. After we do that, we can see that, okay, look, it's compiled successfully. And React is pretty handy in that it does hot reloading. So we don't have to explicitly stop and restart our server every time we change a file. It does that for us, which is pretty nice. So we just have this empty to-dos page. So the very first part of a to-do application, obviously, is you want to have to-dos. So if we want to keep track of a list of to-dos, what do you think the best way to tell React to keep track of a list of to-dos is? There is one specific hook that we talked about today that is going to be really handy for this part. Yeah, hooks. Specifically, the use state hook, right? So what we want to essentially tell React to do, right, is const. We'll name these variables later, but we'll tell React to use state. Specifically, we want to import. So if you don't type the whole thing actually, and you click this one, VS Code will actually auto import for you, which is pretty nice, right? And as you remember from earlier, use state has an initial value. So what we can do is we can populate this with an initial set of to-dos that we want to add. Let's say we want to, what do we want to eventually want to be able to do by the end of this workshop? We want to, let's say, check things off of our to-do list. We want to be able to add new to-do items, and we want to finish this workshop. Smiley face. And useState also gives us back two parameters, and the first of which is the actual value itself, and the second of which is a setter value, which allows us to set this to-dos value. Technically, we can name these whatever we want, but the convention is to name the thing on the left, the variable, and the thing on the right, set, and the name of the variable. So we have our to-dos here. So if we save it, nothing happens right now because we haven't rendered any of that to the screen. So what we can do right now is, because to-do is an array, we can actually map over to-dos and then turn them into JSX. So what we can do is we can insert a pair of curly braces that tell JSX to actually just interpolate JavaScript here. We can do to-dos dot map, and we take each to-do. So we're just writing an arrow function here that takes every to-do and then returns us, let's say, so let's just return a paragraph tag with the actual to-do inside of it. If we save that, we have a list with all of our to-dos on it, which is pretty neat. But obviously, this doesn't look super functional right now. This doesn't look super clean. If we want to style this to-do element a little bit more, that makes it pretty difficult. So what we want to do is we want to pull out each of these to-do items into its own component. And if you remember from earlier, how we actually write a component is essentially, it's just a JavaScript function, right? So you can say function to-do component is a function that takes 0 parameters, so 0 props, and returns, actually it does take in a prop. We want to essentially take in the props, right? And return this paragraph tag that says props.name. So we're just essentially rendering the name, which we give here. So what we can eventually turn this into is a to-do component, and we pass in the prop by defining it here. So what we're telling React here is create a to-do component and pass in name is a to-do as a prop. So propped here, after we do it, is going to be an object containing name and the value, which is whatever the value of to do is. So if we save this, see that it's exactly the same thing, which is exactly what we want. Obviously, we want to follow proper semantic HTML. So anytime we have anything list looking, we should probably wrap that in a list looking item. So what we can do is use the UL tag in HTML, which tells JavaScript to, oh, sorry, not JavaScript, HTML, that this is unordered list, right? And then we can move this inside of the unordered list right here. So instead of just having a paragraph tag, we can wrap this in the li tag, which is the list item. So this helps us a lot of accessibility. It tells screen readers exactly what this is. It tells the screen reader that you have a list going on here. And generally, just better accessibility, which is what we love to see. After we get to this point, oh wow, we have all these bullet points, which is pretty nice. But we want to have some sort of responsibility, so responsiveness that lets us know that we can actually check things off of our to-do list, right? So let's add some styling that adds some hover effects to this component. So you may have seen from up here, we have this funky looking little bit. It's called the app container. And what we're essentially doing is we're using this JavaScript library called styled components, which allows us to write essentially CSS or SCSS, which is an extension of CSS that lets us style our React components really easily. So let's say const styled to do, for example, is an li tag, right? So that's what we have right here, this li tag right here. And what we want to be able to say is, let's say whenever we hover over this tag, we want to set this paragraph thing inside of the list item to be strike through. So let's say like text decoration strike through. Does that work? I forgot what this looks like. CSS strike through. You'll find yourself when you're writing React feeling a lot of lookup online. So let's look at how we do this. Text decoration line through. Misspoke. So we change this to line through. And now when we go back to here, it doesn't actually do anything because we didn't apply this component anywhere. Actually, you may have noticed that we did style.li. So what we can do really easily here is just replace li here with our style to do component. And what this essentially tells React is it's actually just an li element under the hood with some extra CSS. So if we go back now, whenever we hover over an element, it's very nicely crossed out. We also want to be very friendly to our people who are using this app and indicate that you can actually click on it by setting the cursor event pointer. So let's do that. Now we go back. You can now see that there's the clicky button indicator so that it knows you can click on it. But you actually can't click anything. So let's now talk about callbacks. So what we essentially want to be able to do is be able to click one of these things and execute a JavaScript function. And you may remember from earlier that we used the onClick property to allow us to register things before. So if we go back here, for example, go back to our to-do component, what we can do is say onClick, right? And then declare a function, right? So this function executes every single time that this to-do is clicked. So the basic, obviously, is just console log whatever props.name is. So if we open up by going to F12, we open up our browser, we refresh, click a button, it'll basically print out every single time we click an item, which is pretty neat. But that doesn't actually accomplish the goal of what we want of actually deleting things off of our to-do list. So the way we do that is we have to essentially find a way to modify this to-do state. But you may have noticed that we're actually inside the child of the app component, right? And you may remember from earlier in the workshop, data flows downward. It's very hard for us to go back up the component tree to modify data up above. So the way we're going to kind of cheat the system is we're going to pass down a function to our child component that lets us modify the state. So we can write a helper function inside app that is, let's say, const remove to do, which is an arrow function like so. So This is kind of weird. You may be like wondering, why are we defining a function as a variable? This is more just like a stylistic choice than anything, but because functions in JavaScript are first class, they can be passed around like any other value. So we're just defining an arrow function essentially here that takes in a variable I, which is the index, and then essentially removes it from to-dos. Now we may be tempted to just say, obviously, like to-dos dot splice like I1, right? And just like remove the item. But remember from earlier that to-dos is actually read-only. This is kind of a legal maneuver right here. So the best thing we can do is we have to make a copy of to-dos, right? So let's say copy, and so let's say new to-dos, right, is essentially to-dos like this. What this is this is spread syntax. A lot of this is definitely a newer way of writing a way to copy an array, but I will show you exactly what this does in JavaScript right now. So let's say we have an array that contains 1, 2, and 3. Array is 1, 2, and 3. If we want to copy this array over, what we can do is essentially create a new list, use these 3 dots, which is called the JavaScript spread operator, which essentially takes the array and decomposes it into its separate bits and pieces and assembles them back together. So we just get a new array essentially. But this is also really handy because in the future, what we can do is say comma, and then 4, and then 5, and then 6, and essentially just have a really nice way of appending things onto the end of an array, which is pretty handy for us. So that's just a little bit of JavaScript syntax. But yeah, so now we have our new to-dos. The next thing we want to do, obviously, is remove the to-do we're talking about from our to-dos. So what we can do is we can do new to-dos dot splice at the index we want, so start, right, and then delete count. So we want to delete one item at the index I. Now we have our new to-dos. What we can do now, then we can call set to-dos with our new to-dos. So what this function essentially says is, hey, first of all, make a copy of existing to-dos. Remove to-do at index I, and then set to update to-dos to new to-dos. Hopefully that makes a lot of sense to everyone. So essentially what we have right now is this function, which is defined in terms of a value. And now what we can do is we can pass this remove to-do function into our to-do component so that every time we click it, we can remove it appropriately. So what we want to be able to do, of course, is we can just expand this so it's a little bit easier to read, first of all. Just want to say remove callback. We can name this arbitrarily, but generally callback is a good suffix to a property that contains a callback. So we just pass this function, which is actually a value, into this component. So then we can access remove to do up inside our component right here, right? So instead of on-click console log this, right, we can just on-click remove, sorry, we can just do on-click props dot remove callback. It's pretty nice and handy. But the problem here is remove to do expects an index of I, right? And we're not passing I in right now. So how are we going to do that? What we can do is map actually has a second argument, which gives us this index actually. So what we can do then is we have this I value, right? We can change this then to a wrapped arrow function. So those of you who are more familiar with functional programming, maybe Racket, you've heard of the concept of currying before. What we're essentially doing is we're pre-passing an argument into a function that takes a parameter, so it turns into a 0 argument function. So we're creating a new arrow function that takes in 0 parameters, and just essentially what this function does is it calls remove to do with I. So what we've effectively done is created a remove callback function that does remove to do I, but takes in 0 parameters. Hopefully that makes sense, but what essentially it does now is what it allows us to do. So we go back into our to-do app. We can now click on each of these and check things off of our to-do list, which is pretty cool. I know the last little bit was probably a lot for a lot of people, so I'm going to give another 3 minutes for people to catch up and ask any questions if any last bit of that was confusing. Okay, I will assume that nobody has any questions, and we'll continue on with our next little bit of our workshop, which is adding new to-do items to our app. Obviously, we want to be able to do that with some sort of input. And traditionally, how you would do that in HTML is use a form. So we're going to do something similar like that here as well. So the first thing we're going to do is create a new component. Let's going to call this, let's say, like new to-do form. And take some props and returns, let's say, form component with a single input. Right? That's essentially what we want to do. And yeah, so we want to be able to annotate this input with a few things, right? We want to basically tell people that this is, first of all, this is a text input. Second of all, the value of this is, actually, we will leave this blank for now, but we want to essentially have a placeholder that says add a new to do, so people know what this box is for. And we want to add this component into our app. So what's a good place to add it? Probably after all of our displays for all of the display for our to-dos. So we can insert new to-do form right here. So we can do that, make it look like that, and do that. If we save it and we go back here, oh, it does not seem like it's remembering correctly. Oh, because we created a new to-do component instead of a new to-do form. That is kind of silly. If we did new to-do form instead, now we have this nice looking text box that allows us to do absolutely nothing right now. So the first thing we want to do is I want to be able to keep track of this form state. And so every time we submit to the page instead of the default action, which is to reload the page with whatever is inside this to-do right here. So the first bit of that is we want to keep track of the user input, right? And the way we do that is very similarly to how we're keeping track of to-dos here. We want to keep track of user input. So const, we're going to once again use the useState hook right here. And have the initial value be nothing because we want the text box initially to be very empty. So the two things we want to keep track of is the to-do that we've typed so far and the ability to set the to-do. Right now, this still does nothing. We want to be able to listen to every time someone types something in this input and update this state appropriately. So what we can do is handily, JSX gives us a prop called onChange. So what this does is it allows us to add a callback, which gets executed every time we type something into this input. So what we can do here is onChange. We can do is we take an event in, so the event of the change, and then we set the to-do to be e.target.value. It's a little bit nuanced, but this event is a React change event. If you have VS Code, this should annotate the type for you. But essentially what this does is it takes the event, tells you the target of the event, and from the target of the event, we want to extract the value. So if we do this, then we update the to-do every time we type something. If we want to confirm that, we can do a console log of to-do here, just to make sure we have everything being updated correctly. So if we go here, we reload the page really quickly to reset the page, and then we type React is cool. We can see that we get a console log every time we type something, which is pretty neat, but right now, honestly does not do that much. So what we can do is we want to actually register the value of this. So this tells React we're controlling the component manually. We can bind the value of it to the actual value of the state. So we're essentially telling React, hey, I want the single source of truth for this input, the value of the source of truth, to be this state value right here. And the next thing we want to do actually is notice now that every time we press enter, it submits the form. We actually don't want to do that. We want to handle the input separately and stop the default action. So what we can do right now is write a new handler for handle submit. Okay, so once again, we've taken an event and do something with it. So this is something that we want to pass into this input, this form actually, that says on submit every time we submit this form. So whether that be a submit button or an enter key press, we want to execute this function instead of doing its default behavior. So we do handle submit, right? We can do e.prevent default. It allows us to prevent the page from reloading. So if we refresh this and we press enter, nothing actually happens now because we prevented the default action. But what we actually want to do here is we want to set the to-do. Sorry, not actually set the to-do. We want to clear the form first. But before we clear the form, we want to add this to-do to our app. How might we do that? You may have remembered from earlier that we had, for something to modify its parent state, we had to pass a callback into it. So like this remove to-do, we're going to write a new callback helper. This is const add to-do that takes in a single to-do item and adds this to the state of the parent. So like before, we don't actually need to make a to-do copy here, actually, because we have the very handy a spread operator. So what we can do is say set to-dos, right? Old to-dos. Okay, so let's say const new to-dos equals the old to-dos. Then we add the new to-do item at the end. And that way, when we set the new to-dos, it's essentially just appending it onto the end of the list. So what we can pass into the new to-do form is, let's say, like add callback. Okay, and pass in add to-do. So essentially now we have access to props.add callback to be able to add something in. So props.add callback, because once again, this is a function that takes in one argument, right? So we can actually pass in this to-do state, because we told React earlier that this single source of truth for this input box is this to-do state. So we can just pass in to-do into props.add callback. So we can do basically just tell React, hey, I want to add the to-do. So if we save this and we go back, we'll say we want to add a new thing. Yeah, press enter. Look, it adds the to-do list, which is beautifully wonderful. And now we can just delete all the things. And it works, which is pretty solid and cool. Now, I'm getting pretty bothered by how unstyled this to-do input is. So I'm just going to do a little bit of a brief styling little thing right here just to make this input look a little bit nicer. So what we can do is create a new styled component, styled to do input, right? Call it a styled input, and just give it a few CSS properties. Let's give it some good padding for measure. Give it, let's say, border, and round it out a little bit just to make it look nice. And instead, because we already called style.input, we can just replace the input with styled to do input. And nice, we have something nice and styled. It's pretty cool. So that is, in essence, the entirety of our to-do application. Hopefully you're able to follow along with that code along pretty easily. I'll post the full code after the workshop and be around to answer questions if you have any. But yeah, so that's essentially the basis of building an application in React. Obviously, there's a lot more you can do with it, but those are the basics itself. Obviously, React is not limited to the framework itself. React has an entire rich ecosystem surrounding it. And React's utility goes beyond the framework itself. It's not just React, the framework itself. There's a bunch of other tools that surround React that make it really easy to use. You may have heard some of these mentioned during Keva's workshop. There's a lot of different useful tools and libraries that you can use in your React applications. So for styling, we use styled components to styled components for this. Styled components to styled components for this workshop. But there are other libraries like Tailwind CSS and Chakra UI that allow you to do something similar as well. There are other libraries like state management. So Redux, MobX, and SWR allow you to basically manage state in a lot of larger applications more easily. Deployment, so we're going to throw your React application onto the internet. Vercel and Firebase make that super easy. And server-side rendering, so if you don't want the client to load everything, we can pre-render the pages and then send them to client as well. Those are essentially useful tools. Obviously, there are a bunch more I haven't explicitly named, but here are some that I found useful in the past as well. But yeah, one thing to be wary is that obviously you can't use everything for, you can't use all the packages. You will eventually reach something called dependency hell, where you'll get to a point where, unfortunately, you have way too many packages to deal with, and resolving them is a pain. So there is a reasonable limit to using packages. But yeah, that reaches the end of our workshop. Here's a really fast legal bit at the end of all those infomercials where you see all the possible side effects of legal clauses, but we don't have any of that because this is a workshop. Thanks again for coming to this workshop, and hopefully you learned a little bit about React and give some good foundational knowledge to continue you on your React journey. And yeah, cool. And hopefully this workshop is a good basis for you to eventually build projects that help the world. And yeah, that concludes the end of our workshop. And if you want to basically qualify for stamps, I think we'll be running a stamp collection in a few seconds. So if you want to claim ownership of participating in this, please react to the stamp message. But yeah, that concludes the React workshop. And thanks again for coming, everyone.